This is our first video in our scripting series. In this video, we are going to learn basic to intermediate scripting using the Lua language. Before using Lua in Game Guardian, let me give you some basic knowledge about Lua's core concepts. If you want to directly use Lua in Game Guardian, you can jump to the next section using the timestamps in the description. But remember, I won't explain the syntax already covered in this section. In this basics of Lua, we are going to discuss variables, data types, operators, conditional statements, loops, variables. Write variable description here in just 2 lines. To understand this easily, see, we have data here, and we need to store it somewhere for later use. So, I use a box here. This box is now our variable. Similarly, we have another value and save that in another variable. Think about it, for a computer, it points out the exact values by their address. But for humans, it's hard to remember the addresses, right? So, for our convenience, we give names to our variables. With this, it's easy to remember. Whenever you name a variable, you need to keep 2 things in mind. A variable must start with either a letter or underscore. A variable must not start with a number. A variable must not contain spaces. Data types. Nil represents the absence of a value. Boolean represents true or false. Number represents numerical values, floating point. String represents sequences of characters. Function represents executable code. Table represents associative arrays or objects. User data stores complex C data structures. Thread represents coroutines for multitasking. In these data types, you already know about nil to string by just looking at the description. So you just need to know about function to thread. We will discuss these one by one with direct examples in the game, so don't worry about it much. Now let's see how we can save data in variables. For example, we have a value 999,999. Let's store this in a variable. Let's name this variable as my_coins. Now we have stored our 999,999 value in our my_coins variable. Now we know how to create variables and store data in variables. But how can we use it or see what's contained in our variable? For this, we have the print function. This is a built-in function used to output values or messages to the standard output. It's commonly used for debugging and displaying results. We can print numbers, floats, strings. While printing strings, we need to place that string between single or double quotes. Both are fine, and for strings, we only use quotes. If you have a single quote in the string, then put your string between double quotes, otherwise, you will get an error. Let's print our value in our variable. See, we got our value. Arithmetic operators, just calculations we already know about, but let's see how to use them in Lua. Creating a file with a .lua extension. Here, I've already created my file with the name tutorial and the .lua extension. I use MT Manager's default editor. You can use your favorite editor, but make sure your file extension is .lua. Now, let's perform arithmetic operations on 2 values. Now, I save this file. Now, let's run this code in Game Guardian. We already know how to run a script in Game Guardian from our tools explanation video. I'm not going to explain it again. See, we got our results. Let's understand logical operators. An operator returns true if both conditions are true, otherwise, it returns false. Or operator returns true if at least one condition is true, otherwise, it returns false. Not operator returns the opposite of the condition, if the condition is true, it returns false, and vice versa. See, I am storing the value 35 in the age variable. Now, let's use the AND operator. According to these conditions, if the age is greater than 25 and less than 40, both are true. This means our AND operator is satisfied, so we will get the output as true. Now, I am going to set one variable to false and another one to true. If we want to get true while performing the OR operator, we need at least one condition to be true. Here, we have one condition that is true, so our output will be true. Now I set true to a variable. As we know, the NOT operator just gives the opposite result. That means if you get true, it changes it to false. If we get false, it changes it to true. If statement checks if a condition is true and executes code accordingly. Let's see its syntax. If condition then block of code. And here, you need to put your condition between if and then. After that, whatever code or tasks you write in the if block will be executed if the condition is satisfied. You must put the end keyword after the block to indicate that the if block ends there. Let's take an example. I store 18 in the age variable. And I take age equals 18 as a condition. If the condition is true, then only the person can access the website. Otherwise, the person can't access the website. Else statement executes code if the previous if condition not true. Let's see its syntax. If condition then block of code. Else block of code. End. If you observe else block, we didn't mention any condition because it doesn't need any condition. If the above conditions not satisfied, then automatically else block execute. Let's take previous example. If you observe in previous example, the code will execute if condition satisfy, otherwise we will not get any output. But this time we can get the output. Let's see. This time I take 10 int of 18 for age variable. Like we discussed before, if condition not satisfy, then else block will execute. In our case the user age is just 10, so if condition not satisfy and the user can't access website. Now we can display a message to the use. If statement used to check additional conditions if the previous if condition is false. Let's see its syntax. If condition then block of code. Else if condition then block of code. Else block of code. End. If you observe, else if just looks like the if statement. As we already discussed in the definition, it's just an additional condition. If the previous condition is not satisfied, then it will check the else if conditions. Like this, we can create number of else if statements, but the if and else conditions must be one each in the conditional statements block. This time, I take the value 15 for the age variable. As we discussed before, if the condition is not satisfied, then it checks the next condition. Now, the else if condition is satisfied, so it will execute the else if block. Loops. Loops are basically used when we want to execute a certain task or a particular block of code for a certain number of times. We have 4 types of loop. Numeric for loop. Iterates over a range of numbers. Syntax. For I equals start, stop, step 2. Block of code. End. Here we want to specify where we want to start our iteration and where to stop. If you want to skip any steps between, like 2 numbers between 1 to 10, then we get 1, 3, 5, 7, 9. If you don't want to step, then leave it blank. For example, I want to print numbers from 1 to 5. For I equals 1, 5 do. Print, I. End. Here, first, I is 1 and enters into the block and prints I value. Then its value changes to the next number, which is 2. Then again enters into the block and prints I value, which is 2. Then it changes to 3 and enters into the block and prints the value. This loop prints until the number 5. After that, it changes to 6 and checks the condition. We just iterate 5 times only, so it exits the loop. See, we got numbers from 1 to 5. Generic for loop. Iterates over key value pairs in a table. Previously we saw how to iterate on numbers. This time, let's see how to iterate on tables. Both loops are the same, but the use case is different. Let's see the syntax. For key, value in pairs, table, do. Block of code. End. If you don't understand what key, value, and table are, don't worry. Let's see an example, and then you can understand. Details equals channel equals 10 Ramsey, subscribers equals 360. See here, details is our table. Channel and subscribers are our keys. 10 Ramsey and 360 are the values of our keys. Let's perform a loop operation on this. For k, v in pairs, details, do. Print, k, v. End. If you see in the output, it prints our details. While loop repeats as long as a condition is true. Syntax. While condition do. Block of code. End. You might think it just looks like an if statement. Yeah, it looks like that, but here it continuously executes the block until the condition is true. In an if statement, we just execute the block only one time. Count equals 1. While count less than equal to 5 do. Print, count. Count equals count plus 1. End. If you observe here, we increment our count. Because, like our for loop, we don't have a range or starting to ending point here, so we need to specify increment or decrement in the loop. Otherwise, the count will stay at 1, so the loop will not end. It will print infinite times because it satisfies the condition less than 5. There are some scenarios where we need to execute our code at least once without checking the condition. In that situation, we have a loop. Repeat, until loop. Executes a code block at least once, then repeats until a condition is true. It just looks like the do while loop in the Java language. Anyway, let's see the syntax. Repeat. Block of code. Until condition. We can see on some websites they provide their service only one time for free, then we need to purchase it. Otherwise, we can't use their service. Let's see an example. Subscription equals false. Repeat. Print, access approved. Until true. See, it only prints one time and checks the condition. To repeat loop it need true but we have false so it exits the loop. A function is a block of code that performs a specific task. Functions can take parameters and return values. They help to organize code into manageable sections and allow for code reuse. We have 2 types of functions. Pre-built function. Pre-built functions are standard library functions provided by Lua for common tasks like string manipulation, table handling, and mathematical computations. Example, print, table.insert, and math.random, are examples of pre-built functions that simplify tasks in Lua. User-made function. User-defined functions are custom functions created by the programmer to perform specific tasks or encapsulate reusable logic within a Lua script. Example, we can create our own function, and here I'm not using parameters. This is simple function. Function my function. Print, this is my function. End. My function, calling my own function, this will return this is my function as output. Introduction to Game Guardian Lua scripting. Standard Lua scripting. Lua is a lightweight, high-level programming language. In standard Lua, you work with basic programming concepts such as variables, loops, conditionals, and functions. Game Guardian specific API. Game Guardian enhances Lua with additional functions that interact with the app. These functions are prefixed with gg to indicate they are part of the Game Guardian API. So in Game Guardian scripting, most of the functions we use are from the Game Guardian API. These are not included in standard Lua language. If you see any functions or methods starting with gg, it means it's related to the Game Guardian API. In standard Lua, we don't have a built-in function to create an alert dialog. However, in Game Guardian, we have gg.alert, which allows us to display a pop-up message to the user. Here you can see the syntax. Let's see an example. Here, I create a file with the .lua extension. I enter the text. Let's open Game Guardian. Select the file path here. Let's run it. See, we got our pop-up message. If you observe, by default, the positive position is set to OK. Let's change this to yes. See, it changed. Now, let's set values for negative and neutral as well. See, we set our values. If we click on those, nothing will happen because we didn't specify any task to them. Let's specify some tasks to them, so if we click on them, they will do that specific task. For now, I just want to display some messages. But before that, we need to store that response in some variable because, as we already discussed in our theory part, for using a value or result for repeated use, we need to store them somewhere, right? Whoever skipped our theory part might not understand this well. So I am storing this in a variable and naming it as alert. Now, I want to display a message when the user clicks on the yes button only. So that means we want to set a condition for our task to execute. We already discussed in our theory part, so we know what we need for this kind of situation. We need conditional statements. Let's use it. As we see in our gg.alert function description, the positive position returns one value. So, if alert equals 1, then print good. End. See, when we click on yes, it displays the message. But if we click on the remaining options, we don't get anything. Because we didn't set any task for those buttons. Let's set some tasks for those as well. For additional conditions, what do we use? Do you remember? If you said else if, you are right. That means you are on the right track. For negative, it returns 2, and for neutral, it returns 3. Let's use it. Else if alert equals 2 then print, bad. If the user does not click on yes or no, then we just have the maybe later option. So instead of creating an else if statement, we have another statement. What is that? If you said else statement, you are right. For this, we don't need to enter a condition because it's the last option, right? Let's use it. Else. Print, subscribe for more hacking content. End. Let's see the output. See, everything works properly. .toast. This is used to display a temporary, non-intrusive message on the screen. This message, often referred to as a toast, appears for a short duration and then disappears automatically. It is useful for giving quick feedback to the user without interrupting the flow of the script. Syntax. gg.toast, text, fast. Parameters. Text: the text to be displayed in the toast message. This parameter is required. False: this is bool type, by default it's set to false. If you set to true, then it disappear. Fastly compare to default. I want to display a toast message after the conditional block. See it display our message. As we discussed before, the fast parameter set to false. If you set to true, it disappear fastly than before. gg.sleep. This is used to pause the execution of a script for a specified amount of time. This can be useful when you need to wait for certain conditions to be met or to create delays between actions in your script. Syntax. gg.sleep, milliseconds. Parameters. Milliseconds: the number of milliseconds to pause the script. This parameter is required and should be a positive integer. I want 10 seconds gap between executing conditional block and toast message. I enter 10,000 as millisecond parameter. Let's see. See, after execute the conditional block it took 10 seconds delay to display the toast message. gg.choice. This is used to display a list of options for the user to choose from. This function is particularly useful for creating interactive scripts where the user needs to select between different actions or settings. Syntax. gg.choice, items, selected, message. Parameters. Milliseconds: a table, array, of strings representing the list of options to be displayed. Selected is not specified or is specified as nil, then the list will be without the default choice. Message: the title of the choice dialog. If not specified, the default title will be used. Let's use it. I'm taking coins, gems as my items. With this function we can only solicit one item at a time. Remember, if you not follow the syntax you will get error. Let's run it. See, we got our output. Now I want to select cons by default. So if user didn't select anything, then the coins will take as selection. See, it's selected. Now I want to set title to my script. See its work. Remember, if you want to perform any tasks on it, then you need to store its RESP once or result in a variable like we did in previous example. gg.choice. This is used to display a multi-choice dialog box that allows users to select one or more options from a list. This function is particularly useful when you need users to make multiple selections or configure settings within your script. Syntax: gg.choice, items, selected, message. Parameters: items. A table, array, of strings representing the list of options to be displayed. Selected: a table specifying which options are selected by default. Each entry should be true or false, indicating whether the corresponding option in the items table is pre-selected. If this parameter is omitted or set to nil, no options will be pre-selected. Message: the title of the choice dialog. If not specified, the default title will be used. Let's use our previous example. Here let's change choice to multi-cheek. Remember one thing, function names must start with small letter and remaining words start with capital letters like this. See, now we can select multiple choices. Now let's see how to set the default selections. See, it works. Now let's UE this our starting script. Here if we click on yes, it will show good. But now it will show our items. See, it's working. If you click on remaining optitons, it don't show our items list. It will display previous messages. gg.prompt displays the dialog for data entry. Syntax: gg.prompt, prompts, defaults, types. Parameters: prompts. A table containing the names, as strings, of the input fields you want to display in the dialog. Defaults: a table containing the default values for each of the input fields. This parameter is optional. Types: a table specifying the data type for each input field. We can include the valid types like number, text, path, file, speed, checkbox, seek bar, etc. Let's use it. Now, I am creating some prompts for different data types. When creating a seek bar, you need to put square brackets after your prompt. In those square brackets, you need to specify the starting and ending values for your seek bar, separated by a semicolon. For this example, I take 1 as the starting point and 100 as the end point. Now, coming to defaults, you can leave it as blank or set it to nil. Let me set my seek bar default value to 50. We already know how to set the default, right? If you want to set default values for everything, then there is no need to specify the key value. Just set default values in order. If you want to specify default values for only some of them, then you need to specify their key value, like I did here. Now let's set the type for each one. If you don't specify the type, by default, it takes everything as a number type. I am setting every data type in order, meaning for the first one, a number, the second one, text, and so on. See, we got different types of input fields. Now let's enter a number. If you watched our previous videos or tools explanation video, you already know about these options, so I am not going to explain them. Now let's enter a name. For this, it doesn't have the drop-down option like previous because it's not a number type. Now, let's enter the path. If you know the path where you want to perform a task, you can enter it manually or paste the path here, or even you can select from here. See, it only shows the folders. Now, let's select the file. See, now it shows files also. Sorry, I accidentally clicked on OK. Let's re-enter those. Now here, we need to set the speed. Now here, we can see our seek bar. If we click on OK, it doesn't give any results because we didn't set any task to those operations. We just gave input. But don't worry, we'll use this in our script like we did with the multi-choice function. But before that, we need to learn the remaining things as well. Like how we add our multi-choice to our script. We all know when we start our search, we need to set our ranges, otherwise, Game Guardian will take default memory ranges. We all know when we start our search, we need to set our ranges, otherwise, Game Guardian will take default memory ranges. But mostly, we use those because it sets all basic memory ranges by default. In scripting, we also have a function to set our memory range. We can set multiple memory ranges at a time by separating them with a bar. Let's see the function and its details. gg.setRanges. This is used to define specific memory ranges that the search operations will target. This function allows you to narrow down searches to specific areas of memory, making the search process more efficient and effective. Syntax. gg.setRanges, ranges. Ranges. Region_anonymous. Region_ashmem. Region_bad. Region_c_alloc. Region_c_bss. Region_c_data. Region_c_heap. Region_code_app. Region_code_sys. Region_java. Region_java_heap. Region_other. Region_ppsspp. Region_stack. Region_video. I will show you how to use this in searching for values. Now, let's see what features we have in the searching tool. Here, we need to enter a value. Here, we have relational operators. Here, we need to set data types. This is used to set whether our values are encrypted or not. This option is used to set memory ranges. Here, we have 169,000 coins. Now, let's see which function we have for this search. gg.searchNumber. This function is a crucial part of Game Guardian scripting, allowing you to search for specific values within a game's memory. Syntax. gg.searchNumber, text, type, encrypted, sign, memory from, memory to, limit. Parameters. Text, string for search. The format is the same as the format for the search from the Game Guardian UI. String, the number or numbers you want to search for. This can be a single value or a range of values, separated by a semicolon, winky face, for example, 100 or 100, 200. Type. Type_auto. Type_byte. Type_word. Type_d word. Type_XOR. Type_float. Type_quord. Type_double. Encrypted, Boolean, set to true if you want to search for encrypted values, otherwise, false. Sign, sign. One of the constants sign_star. Sign_equal. Sign_not_equal. Sign_less_or_equal. Sign_greater_or_equal. Memory from, start memory address for the search. Memory to, end memory address for the search. Limit, stopping the search after finding the specified number of results. 0 means to search all results. Now I enter the value in between single quotation marks, but you can enter a number directly with no problem. Because it's not a hex value or address, there is no problem. But I will recommend using quotations for good practice. Now, let's enter the data type. These two parameters are mandatory. The remaining will be optional. Because the remaining will take default values like encrypt is false, sign is equal, memory starts from 0 to last, and limit will be 0. But here, I will set the encrypt parameter to false just to show you. Now, let's run this. See, it worked. I'm removing this. Now, let's use the memory range to set manually. As we discussed before, we can set all memory ranges at a time. I know my value is stored in the anonymous range. But I use c_alloc also. Because to show you how to set more than one memory range. See, it's working. Remember, the syntax is important. If you miss anything or by mistake enter extra or different symbols, it will give you errors. Now we know how to search values with a script. We obviously need to refine the values, right? For this, we have the refineNumber function. The refineNumber function is similar to the searchNumber function. The only difference is the function name, the remaining details are the same. gg.refineNumber. This is used to narrow down search results by filtering out values that do not match a specific criterion. Syntax. gg.refineNumber, text, type, encrypted, sign, memory from, memory to, limit. Parameters. Text, the value you want to refine. Type, one of the constants type _*. Data types. Encrypted, Boolean, set to true if you want to search for encrypted values, otherwise, false. Sign, one of the constants sign _*. Memory from, start memory address for the search. Memory to, end memory address for the search. Limit, stopping the search after finding the specified number of results. 0 means to search all results. For this, let's take our previous script. We already know that the refineNumber function and the search function are similar, and how to search with a value by directly specifying it in the script. This time, let's take the value from the user to refine the value. We already know how to get values from the user, right? Tell me the function name. If you said prompt function, you're right. Let's use that function here. I just need one value from the user, not multiple values. I will use only one prompt. The default value is nil. I set the type to dword, but you can set it to number like we did in the prompt example. Now I'm storing the result in a variable named value. Here we are taking only one value from the user. So the list of values is 1, and that value is the first value. So, I create a new variable named refine. In that, I store the first value from the value table. Now, in the refineNumber function, I give the refine variable in the value place. It will take the value inside the refine variable to refine the search. And I set the data type to dword. Is there anyone who can spot a problem in this script? If we use this script, we can't refine the value to filter results, we will get the same results. Because, between our initial scan and refine scan, there is no time gap to update our value, right? Actually, While using Game Guardian, we usually play the game for a while or perform some tasks to update the value before refining it. To give time for the next scan, what function should we use? If you said sleep function, you're right. Now I'm going to set the sleep time to 15 seconds. Whoever skipped those functions, please watch those for a better understanding. Now let's use it. See, our prompt is displayed. Let's enter our value. Let's exit the game and check our actual coin value with the refined value. See. Both are the same. If you observe, while we enter our value in the prompt, the game continues running in the background, it's not paused. In some games, if we can't pause the game in the middle of a script, we might die in the game or lose something. For this problem, we have a solution. We can control the process with these process-related functions, and we don't need any parameters. gg.processPause, used to pause the process. gg.processResume, used to resume the process. gg.processToggle, if the process is paused, it will be resumed, otherwise, it will be paused. gg.processKill, kill the process. I like to use toggle instead of using pause and resume. You can use those as well, it's not a problem. Now I am using the toggle function before and after the prompt to show you how the kill process works. I will sleep the process for 20 seconds after refining the value, then kill the process. Let's take our previous value as our initial value. Now, repeat the process. See, the process is stopped in the background. When we click OK, the prompt function will end the process and resume it. See. It's working. Let's end the game and see the results. See, the values are same. Now, let's wait for the process to be killed automatically. See, we didn't do anything, the process was killed by our script. After we search or refine, we see a table with a list of data and addresses, right? Now let's see how to get that list of table. gg.getResults. This is used to retrieve the current search results from the game's memory. After performing a search or refinement, this function allows you to collect the found values into a table for further manipulation or display. This is essential for scripting as it enables you to work with specific memory addresses and values. Syntax: gg.getResults, maxCount, skip, addressmin, addressmax, valuemin, valueMax, type, factorial, pointer. Parameters: maxCount, max count of loaded results. Skip, the count of skipped results from the beginning. By default, 0. Addressmin, the minimum value of the address. Number or nil. Addressmax, the maximum value of the address. Number or nil. Valuemin, the minimum value of the value. Number as a string or nil. ValueMax, the maximum value of the value. Number as a string or nil. Type, set of flags type _* or nil. Fractional, filter by fractional values. If the first character is, then the filter will exclude all values whose fractional part matches the specified one. Pointer, set of flags pointer _ or nil. These are the flags for pointer filters. Pointer _no, this type of pointer indicates that the memory location is not accessible or does not have any permissions set. It cannot be read from or written to. Used to identify areas of memory that should not be accessed or are irrelevant for certain operations. Pointer _read _only, this pointer type indicates that the memory location is read-only. You can read values from this address, but you cannot modify them. Useful for accessing constant data or code sections that should not be altered, such as game configurations or static data. Pointer _writable, this pointer type indicates that the memory location can be written to. You can modify the values at this address. Used for changing game values, such as scores, health, or currency, where modification is needed. Pointer _executable, this pointer type indicates that the memory location can be executed, meaning it contains code that can be run. However, it may not necessarily be writable. Identifies regions where code is stored, such as functions or scripts that the game executes. It's essential for code injection or manipulation tasks. Pointer _executable _writable, this pointer type indicates that the memory location is both executable and writable. It allows both running and modifying the code stored at this address. Used for advanced modifications, such as injecting custom code or scripts into the game to alter its behavior. This is particularly useful for creating game mods or cheats that involve executing custom logic. Now, let's use it. I'm creating a prompt function to give input randomly. Storing it in the n variable. Storing its first value in the value variable. Taking value variable as input value for search number function and taking dword data type. I'm giving a 0 value. See, we got a lot of values, and everything is selected. But I don't want all values. So let's use our getResults function. Mostly, we use the max count parameter only in the getResults function. But to demonstrate to you, I use some parameters. I want only 5 values to select. I don't want any skip, addressmin, addressmax, valuemin, valueMax. So I set those to nil. I set data types dword, chord. We can set whatever data types we want. But if we have the data types in the range we specify, then only it will select. If you observe our results, we have only dword data type on top. So we can't get chord data. We will get 5 dword data type addresses. And it's not factorial, so I set it to nil. And I set the pointer filter to pointer _no. Like I said before, We do not use all these features unless we want advanced filters for complex scripts. Actually, let me make it to 10. This time let's search for 15. See, we got our values, and only 15 values are selected in our table. If you think we just selected 15 values, and we have remaining values also in our table, you're mistaken because actually what we are seeing are selected values visually. After that, we get values in the background. We didn't do any task on that right now, that's why you think like that. Let me show you. Let's save these results in the result variable. Let's print it. If you skip the Lua basics part, you may be confused about this function. It is just for display purposes. What we're getting in the result variable from the getResults function is not a single value type. Let me show you its type also. For this, I am using the type function. Whoever skipped that basic part, if you want to learn more about these, you can watch that basic Lua part. Let's run it. This time change the value. See, it's a table, not a single value. We got all values complete details. Value number. Value address. Value data type. Value. Second value details. Value address. Value data type. Value. Third value details. Value address. Value data type. Value. Like this, we have 10 value details. We can add remaining flags also to this list. That's gonna be interesting. We can save this to our files. We can load those files whenever we want. We can do a lot of stuff. We will learn those all step by step. So don't worry. Now let's see how to edit our results. For this we have gg.editAll function. Before call this method you must load results via gg.getResults. Value will be applied only for results with specified type. Syntax. gg.editAll, value, type. gg.clearResults function. Clear the list of search results. Syntax. gg.clearResults. Let's use our previous script. Now I am removing this variable. Because this function only work on search results as we see in description. It's not work on the results which stored in variables. But don't worry, we will learn that also. Before that let's cover basics. Here I set my edited value, data type. You can take this input from user and use that input as value here. Let's take our coins value. If you observe we set out get results 5. But we have only one value so it select one value only. If we get more values it only select the starting 5 values. And change those 5 only. And our results not cleared. For clear results automatically we have our function, let's use it. Before that see our value changed. I use clear function after the value edit. If you use it before edit. After getting results it will clear entire results. Then you don't have results to edit. So the value can't change. This time let me change our edit value. Our value is 999, so maybe we can get more values. Let's see. If you watched closely, we got more values, but our script selected the top 5 values, and changed those only. Then clear our results automatically. See, our values changed. Now let's learn how to use fuzzy search. gg.startFuzzy function starts a fuzzy search with the specified parameters. Syntax: gg.startFuzzy, type, memory from, memory to, limit. You already know the meaning of these parameters, which is why I am not giving any descriptions here. We already saw how to set memory ranges before searching. However, after completing the script, the ranges will reset to their default state. If you don't want that, we can use a function. gg.skipRestoreState function. Do not restore the state of the game guardian after the script is completed. For example, by default, a set of memory regions is restored after end script execution. This call allows preventing this. Syntax: gg.skipRestoreState function. Here, I am setting my memory range to anonymous. You can set more than one range. Now, I am starting the fuzzy search with a data type. The data type is mandatory. The remaining parameters are optional. They are set to default, like memory starting from 0 to end with the last addresses. Limit is set to 0. We already know all this. See, our memory ranges are set to default before running our script. Observe our memory ranges. See, while our script is running, it stays at the anonymous range. But after completing our script, it changes to its default state. Let's make it stick with our memory ranges. See, now it still sticks with our memory range after completing our script. Now we know how to start a fuzzy search. Let's learn how to refine a fuzzy search. Before that, let's see what features we have. We have unchanged, changed, increased, decreased, memory ranges. If you expand this, we have an option to enter the difference. Data type, relational operators, which is the same as previous changed, unchanged options. Lastly, memory ranges. Let's see this all in scripting. gg.searchFuzzy refines a fuzzy search with the specified parameters. Syntax: gg.searchFuzzy, difference, sign, type, memory from, memory to, limit. See, the syntax is the same as start fuzzy search but with 2 additional parameters. Parameters: difference, difference between old and new values. By default, this is 0. Until now, we have known the normal sign flags. Now, we are going to learn fuzzy sign flags. Sign, one of the constants sign underscore fuzzy underscore star. Sign underscore fuzzy underscore equal. Sign underscore fuzzy underscore not underscore equal. Sign underscore fuzzy underscore less. Sign underscore fuzzy underscore greater. I'm not going to explain the remaining parameters because you already know those. We already know how to search numbers, and this is also the same as that. So this time, let's take this script a little further. Usually, what do we do in fuzzy searching? After our initial search, take some time and refine our values, then take some time for the next scan. It's just like a loop, right? We already know what we need in this situation. Tell me, what can we use now? If you said loops, you're right. But which loop? I just want to scan 3 or 4 times. That means I know how many times I want to loop the task. So, for this, we use a for loop. See, actually, this is what we do. First, we do our startFuzzy function for our initial scan. Then, take some time to update our value. Then use the searchFuzzy function. Here, I am not taking input from the user to check how much difference we get and if this increased, decreased, or unchanged. That's your homework. You already know how to take input from the user for the difference. Give the choice to enter whether increased or decreased, like that. Take that information and make which fuzzy sign flag we have to use. And run the script flow based on conditions. While I am telling the process, you might be getting the function I am talking about. If not, then go and watch again the concepts or the parts you skipped. Let's come to this script. For some values, we don't know how much the values changed, like health, fuel, etc. Then just keep it 0. I am using hill climber for this script. And I know how much value is changing. But for that, I need to use input taking. I am not going to show it now, it's your homework. If you enter the correct difference, you can get accurate results in 1 or 2 scans. Setting it to 0 is also fine, but it will take more scans. Here, I set the flag to greater because while playing this game, we can't lose value. It keeps increasing by collecting the coins and diamonds. So, I set it to greater, and also there is no need to take user input for checking. And I don't use the remaining parameters because it's not a complex task. Those will take their default values. So, these are fine for our job done. Now take 15 seconds for the next scan. It continues for 3 times. So let's use a for loop for this task. I am not going to explain this loop. If you haven't watched the basic Lua, go and watch that. I want to continue the loop for 4 times. So, it will scan for 4 times. So we can get accurate scans now. But this will depend on the game. Some games may take more scans without an accurate difference. Now I am just taking 10 results to edit our values. We all know if we edit the wrong address or more addresses at a time, sometimes our game will crash. Now, I will display a message to get notified. Or you can do one thing in complex scripts. You can create your own function. Let me show you. Here, I create my own function. Name it like lazy. Now in this function, I paste our task. Here, this will call our function each time. Let's see how it works. See our values. See, it worked. Don't forget about your homework. Try to finish it. Until now, we know how to search with values like different types of data and unknown type data with fuzzy search. Now, let's learn how to find addresses. For this, we use two functions. gg.searchAddress. Perform an address search with the specified parameters. If no results are in the results list, then perform a new search, else refine the search. So, if you need to perform a search without refining, you must first call clearResults. Syntax: gg.searchAddress, text, mask, type, sign, memory from, memory to, limit. Parameters: mask, default is -1, 0xFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFfffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffffff them now. gg.refineAddress. Perform an address refine search with the specified parameters. If no results are in the results list, then do nothing. Syntax: gg.searchAddress, text, mask, type, sign, memory from, memory to, limit. Both functions are the same, so I won't mention those again. Now I already know the address of coins, so let's see how to find it with a script. I paste the address here. We don't need to specify hex, it knows that, but we need to enter it in text format, meaning in single quotes. If you know the mask of the address, then you can enter it here. If you don't know, simply enter -1. It's the default, and it will search the entire memory. You can find any address mask using the GameGuardian address searching tool. We already discussed that in our Tools Explain video. Now, I am entering the value type. Remember, these three inputs are mandatory. So, we already enter the exact address, so we get only one value. If we enter more than one, it will give only one result. Actually, it's not 64, it's 6C. Let's run it. See, we got our result. If you do not know the exact value, but if you know the offset, you can do like this. You need to enter memory ranges. I know my address range. Here, there are address types, so we need to use hex or binary specifications. Sorry, I forgot to mention the sign type. See, we got our value. If you don't know the offset, you can also use wildcards. Let's see how. If you are not sure about only one value, then also you can use a wildcard. For example, our offset is 06C. So, if I don't know the last one, then I can set 06. If I don't know the middle one, then 0C. I hope you understand. See, it's showing all addresses in that range we specified. Here is our value. Now we can refine our address. I know it's silly because if you know the address or at least the offset with memory range, we can use it directly in the search address. But not a problem. See, it refines the address. We mostly use this in value searching, like if you know the offset, your value, and don't know the address ranges. After searching values, we need to refine it until we get one or a few values to get accurate results. But here, we know the offset. So after the initial search, just refine the address with offset. Then we can get our value with just 2 searches. Simple, right? There is no need for loop search or function use. Just 2 lines of code. See, it worked without any issue. Let's learn about pointer search. gg.searchPointer. Searches for values that may be pointers to elements of the current search result. Syntax. gg.searchPointer, max offset, memory from, memory to, limit. Parameters. Max offset, maximum offset for pointers. Valid values, 0 to 65,535. I am not going to explain the remaining parameters. You already know about those. I am using the previous example. For those values, we will try to find a pointer. If your value is already stored in the base address, you can't find pointers because that's the base address or static address, right? If your value address is dynamic, you can find pointers. If you didn't find a pointer in that range, then increase the range until 65,535. You can set this pointer value as you want, up to 65,535. You can try on the direct address with address search also. Until now, we have learned basic and mostly used functions in the GameGuardian script. Now let's go further into GameGuardian UI related methods. gg.isVisible. Check if the GameGuardian UI is open. Returns true if the GameGuardian UI is open, or false otherwise. gg.setVisible. Open or close the GameGuardian UI. If you call this too often, your script may be interrupted. Syntax. gg.setVisible, visible. Parameters. Visible, true to open GameGuardian UI or false to hide. gg.getActiveTab. Get the active tab in the GameGuardian UI. Now let's first see how to use the isVisible function. I save the result in a variable and print it. See, we got true, which means our GameGuardian tool is open. Now let's see how to use the setVisible function. I set it to false. When we run the function, whenever it reaches that line, it will automatically minimize the GameGuardian user interface. See, when I click on the run, in a fraction of seconds, it prints the previous command and minimizes it. See, it's printed. Now let's use getActiveTab. First, I am going to search for some value. Now, let's see where we are. Now, let's take that value address. I am going to that address location using the gotoAddress function. As the name suggests, it goes to the address location. Now let's get the active tab. See, we are currently in Searching tab 1, which means the Searching tab. See, now we are in 3, which means the Address tab. 2 is for the Saved List tab. I hope you understand. Now let's learn about another topic. Results-related methods. gg.getResultsCount, get the number of found results. gg.getResults, get the specific number of found results. gg.editAll, edit all selected results. gg.clearResults, clear the list of search results. gg.removeResults, table_results, remove results from the list of results found. gg.loadResults, table_results, loads the search results from the table. gg.getSelectedResults, returns the selected items in the search results. Now let's print our results count using gg.getResultsCount function. See, we got our results count. Let's verify it. See, both are the same. Before we learn about removing results, let's just quickly recap our clear results and how it works. I am going to copy those first 5 results into a variable and clear the results. See. It clears the entire results. Is it clear in our table also? Let's see. See, this clear function only clears the GameGuardian internal search results, not our copy. Now let's see the remove results function. We need to give the table here. It will take the table list we specified and remove those from the GameGuardian internal search results list. Not from our variable. Now, our search results and our variable values are the same. But still, let's print those separately. Now, let's remove the results. Then reprint those again to compare. In this example, we have the same value and data type for those 5 values. So let's focus on the address so that we can differentiate the values. Observe the address. This is our search results. This is our table in the R variable. This is the search results after removing. See, the addresses are different. This means the list we gave to remove is removed from our search list. That's why it takes after 5 results. Lastly, we have our table again, which is stored in the R variable. It's not affected. For better understanding, I placed these all side by side. The left 2 are before removing, and the right 2 are after removing. I hope you understand now. Now, let's load our values again after removing values using the gg.loadResults function by providing the table results. See, all results are the same. It means it restored after results were removed. I display them again side by side. Now I hope you understand better. Let's learn about the selected results function. See, we don't need to specify any parameters in the selected results function. First, let's print those functions. Actually, let's make it 3. See, both get the same results. So you may think, what is the difference between them, and why do we need to use this? Let me show you one thing. Now I will sleep the script for 15 seconds. Let's see what happens. We all know getResults only picks the first values based on count and parameters. From those 3 values, I like to select only the last value. See what happens. See the comparison. This time, we got only one value which we selected. We can't do this with the getResults function. Because until we get results, We don't know what results we are getting, right? That's why we use this to select manually. I hope this will clear the difference. Memory editor related methods. gg.gotoAddress, address, go to the address in the memory editor. gg.getSelectedElements, returns the selected addresses in the memory editor. We already see how to use GoToAddress. Now, this time, let's focus on getSelectedElements. This script searches a value and stores its details in a variable, then takes its address into another variable. The goto function will take us to that address. Now, we will sleep the script for 15 seconds. Then, we can select the desired address to take those addresses. Let's see this practically. See. I selected 2 values. It gives those selected addresses in decimal format. If you don't believe me, let me prove it to you. I am copying this. Now, use our calculator to convert decimal to hex. See, the addresses are the same. We mostly use this for complex scripts or finding XOR or anti-cheat values, etc. Now, you can take the address and edit those values through scripts. We already know how to edit, right? I hope you understand this concept. Until now, we've learned about address tab and search tab related functions. Now, let's learn about saved lists related methods. gg.addListItems, gg.getItems, gg.removeListItems, gg.getSelectedListItems, gg.loadList, gg.saveList, gg.clearList. You may think these look like result-related methods. Yeah, some of them do look like that. But those are related to the search tab, and these are related to the saved list tab. First, look at the values. I am going to group search these 2 values. See, we got our values. Until we add these values to the saved list, we can't freeze the values. For that, we can use the gg.addListItems function. gg.addListItems. Add items to the saved list. Syntax. gg.addListItems, items. Parameters. Items, a table with a list of items to add. Each element is a table with the following fields. Address, long, required. Value, string with a value, optional. Flags, one of the constants type _**, required. Name, optional. Freeze, boolean, optional, default false. Freeze type, one of the constants freeze _**, optional, default freeze _normal. Freeze from, string, optional. Freeze to, string, optional. Flags for freeze. Freeze _normal freezes the value, not allowing it to change. Freeze _may _increase allows the value to increase but does not allow it to decrease. Freeze _may decrease allows the value to decrease but does not allow it to increase. Freeze _in range allows the value to change only within a specified range. Now, let's take this selected result into a variable. Now, take that table list to the saved list by using the gg.addListItems function. Remember, the table items parameter is a must. See, it's saved to our list. Until now, we've seen these tables more times. And we observed that only 3 items will be stored in the table by default. We don't see any freeze-related items, right? We already know the attributes and flags, right? Here, first, I am setting items to the first value, which means coins. I am using a normal freeze. I add items to the list before adding them to the saved list. You can add these items before or after adding them to the saved list. See the difference? Let's add items to the second value also. See, this time I use freeze may increase. I leave the remaining as default. If you want, you can add those also. Remember, don't forget the value formats. If it is specified in string format, then you need to enter those values in between single or double quotes. See, this also changed. According to this, the first value will stick to the value. And the second value can increase but not decrease. In some games, while playing, the values might get changed, but those are just display values. When you come to the lobby, it will come back to its frozen value. This game is the best example of that, so let's see. Observe the values. See, it's working. Let's copy the list to a table using the gg.getListItems function. See, we got our copy. Now, let's learn to remove specified results. gg.removeListItems. Remove items from the saved list. Syntax. gg.removeListItems, items. Parameters. Items, the table as a list of tables with addresses. Or the table as a list of addresses. Now, let's remove the list from the saved list that we specified. See, we clear the list, but still, we have our copy. Yeah, I know it's just like the gg.removeResults function. But for this tab, we have to use this only. Now, let's get selected results only by using the gg.getSelectedListItems function. We already know the process. See, we added 4 results to our add list, but we just took 2 values manually. But how do you add those selections only now? We can select those only before adding to the add list. But in some scenarios, we have to select those after the add list. Anyway, for resaving the save list with only our selected items. After copying our results to a variable, clear all results with the gg.clearList function. Then add those selections to our saved list. See, it removes all and saves with the selected list. This is not the only way. You can select the unwanted list and save it in a variable. Remove those with the gg.removeListItems function. You may have doubt, then why we use this. For this example, both are fine. If you have 500 list items, but you need only 2 or a few values only, then using clear and save selected list is best. But if you have the same 500 results, but you don't need a few values, then select those few values with the selected function and then remove those with the removeList function. Use wisely. Now let's learn how to save the selected list. gg.saveList. Save the saved list to the file. Syntax. gg.saveList, file, flags. Parameters. File, the file to save. Flags, save as text with gg.save_as_text or by default it takes 0. See here we already have a script for adding values to our saved list. Now let's enter the file path. I am creating a new file with the name dummy.txt. And leave it blank so it takes 0, or you can set it to 0. See, we don't have the file here. See, the script is completed. Let's see if it creates the file or not. See, the file is created, let's open it. See, we have details. If we enter 0, we get the same results. See, same results. See, we have our variable name. Address. Data type. Value in hex format. If you convert it to decimal, we will get our value. And we set freeze true for these values, so we got 1 for both. We set normal freeze to this, so we got 0. For the next one, we set it to may increase, so we got 1. And we leave the value range default, so we got 0. It's not a human readable format, so let's save it as text. See, now we got text format. Now it's more readable than before. Now let's see how to load this value. gg.loadList. Load the saved list from the file. Syntax. gg.loadList, file, flags. Parameters. File, the file to save. Flags, Load flags gg.load underscore asterisk or by default it takes 0. Load flags. gg.load underscore values underscore freeze, load values and freeze. gg.load underscore values, load values. gg.load underscore append, append to the list. Let's enter the same path, and I just need to append the values. If you want, you can use those also by separating them with a bar. We already know to separate single attribute flags by a bar. Let's run it. See, the script is completed, but why is it not loaded? Because our data is stored in a human-readable text format. How does the machine understand this? So when we need to load our file, we need to use the previous format. Let's save it in that format. See, we save it in our previous format. Let's try this time. See, it works. I hope you understand. Now we completed all our tabs. Combine all these functions to make the best scripts. Keep practicing all functions to remember them. Anyway, let's move on further. Memory ranges related methods. gg.getRanges returns memory regions as a bit mask of flags region underscore star. gg.setRanges int ranges sets memory regions to the desired bit mask of flags region underscore star. We already know how to set ranges, so now let's learn about get ranges. This will give us a bit mask. See here our default memory ranges are set. If we run it, it will add all bit masks and display the result. See, we got the result. Let's select a single memory range and let's see its bit mask. See, we got the bit mask of the anonymous range. Values related methods. gg.setValues, table values sets the values for the list of items. Basic keys are required, address, flags, value. If provided, we will get true, otherwise, we get an error. gg.getValues, table values gets the values for the list of items. gg.getValuesRange, table values gets the memory regions for the past value table. See, I have my coins and diamonds addresses here. Now I want to store them in a table. Until now, we get the table by copying from results. Now let's create our own and set some values to its items. Let's see the format to create the table. We have two ways, so you can choose one. Observe carefully. These curly brackets are the table symbols. I want 2 items. If you observe, I put a comma after the first item, but after 2 I didn't put a comma. Because it's the last value, we don't need to put a comma. I add values to our items, separated by commas. Now let's continue with second also. Let's see. See, nothing happened. Because we didn't set the values. See, now it's applied. This is how we actually write. Let's see the second way. First, declare the table. Now let's declare the values. Now let's add items. Remember, these three key items are required to set values, otherwise, you will get an error. See, this is the other way. Now, let's change values of results with this function. You may think we have the editAll function. But with that, we can only set a single value and data type to all values. But this is not like that. We can take each value and change each element. See, I set different values to different values. Now let's use the getValues function. This is used to get or copy values from an already created table. See, I get a result table from results and save it in a variable. Now let's copy the table to another variable. Now let's use this on a direct table. I created a simple table. You may think I missed the values. I did it intentionally to show you something. And I am not setting values here just to store some values in the table, so no problem. See, I didn't add a value, but it was added here because it's mandatory. If I try to set it like this, I will get an error. But I just try to copy the values. So if there is no value, it takes 0. It does not work with address or data type. Let's move on to the getValuesRanges function. Whatever table we give to this function, it will get those values memory ranges. See, we got anonymous. It's obvious because I set it to anonymous. If we set it to more memory ranges and if our value is in those ranges, then we will get those ranges in this display message. Speed hack related methods. gg.timeJump, string time performs a time jump. Enter time in string format. gg.getSpeed, gets the current speed from the speed hack. gg.setSpeed, double speed sets the speed of the speed hack. If the speed hack was not loaded, then it will be loaded. The call is blocking. The script will wait for the speed hack to fully load. Parameters. Speed, desired speed. Must be in the range 1.0e9, 1.0e9. The time jump function is useful in some survival type games or any games related to days. With this, we can jump to that time or date to collect rewards or items. Make sure to enter time between single or double quotes. I want to jump 1 day, 24 hours, 60 minutes, and 60 seconds. This is the format, or you can just enter it in seconds, like if I want to jump for 1 hour. Calculate the seconds for an hour, which means 3,600 seconds. I don't have any game to demonstrate, but you can try it. Now let's see how to get the speed. See, we got 1, which means normal speed. Now set speed. Remember, if we want a speed hack, we need x86 libraries in the game. Some games do not have those means, and it might not work for speed hack. For me, I don't have those speed support games right now. You can try it on your own. But let me show you how to use it. See, I set speed to 4. See the message. Debug-related methods. gg.getFile gets the file name of the currently running script. gg.getLine gets the current line number of the script being executed. Now let's print those two. See, we got the file name along with the path and the currently running script line. You may think we have 2 lines of code, that's why we got 2. No, it's not like that. If you sleep your script in the middle of the script and use this function, then you will know on which line the script is currently on. Try it. Public member functions. gg.copyMemory copies memory. gg.dumpMemory dumps memory. gg.getRangesList gets the memory starting and ending point in the selected process. gg.getTargetInfo gets a table with information about the selected process if possible. gg.getTargetPackage gets the package name of the selected process, if possible. gg.isPackageInstalled checks whether the specified application is installed on the system by the package name. gg.require checks the version of GameGuardian. gg.copyMemory. Copy memory. Syntax. gg.copyMemory, from, to, bytes. Parameters. From, address for the source of the copy. To, address for the destination of the copy. Bytes, size of memory to copy in bytes. Example. If I want to copy from address 9000 to 9010 in 3 bytes of size, this is the format. Remember, you need to enter the size in bytes only. gg.copyMemory, 0x9000, 0x9010, 3. gg.dumpMemory. Dump memory to files on disk. Syntax. gg.dumpMemory, from, to, dir, flags. Parameters. From, address for start dump. To, address for end dump. dir, directory to save dump files. Flags, by default, it is set to nil. You can set it to gg.dump_skip_system_libs to skip system library files. Example. Now I am going to create the folder. I want to dump from the starting to the end address, so I set from 0 to -1. -1 means the end address. If you convert this into hex, you will get 16 Fs, which means the last address. You can specify the address where you want to start and end for the dump. Then you need to specify the folder path in string format. I want systemlibs also, so I don't mention the skip attribute. See here, you can see -1 replaced with 16 Fs. Let's see our files. See, we got our files here along with system libs. This is how we can use the dump. gg.getRanges list gets the list of memory regions of the selected process. Syntax: gg.getRanges list, filter. Parameters: filter, the filter string. If specified, only those results that fall under the filter will be returned. Optional: the filter supports wildcards. Caret, the start of the data. $, the end of the data. Asterisk, any number of any characters. 1 of any character. Example: let's get the ranges. See, we have the list. Here you can see the specific file and address, file name, starting address, and its state. Permissions. For this, we have only read permission. Here, we have read and write for this file. Here, we don't have any permission. Here, we have read and execute permission. If you want to get a specific file range, you have to specify its name in string format. See, we have only 4. If you don't know the full name, then we can use wildcards. These are filters. Now, if you know the starting name, then put asterisk after the name. If you don't know the starting name, then put asterisk at the start. See, this time, we got a lot of values because whatever file name starts with the specified name, it will take all those ranges. Use other wildcards like this as well. Special use. If you only want the starting and ending address of this process or game, use this format. Now, guess the format for the end. If you think this is wrong, see the end color is different. Because we all know we use end in functions to tell the script the function ends at that point. So, we need this format. Watch closely. See, we got the starting and ending address. We can get all possible information about the APK or game or target process with this function. See all this information. If you scroll to the bottom, you will see we got info about the target process. File path. Class name. Flags. Installer. Label. Package name. Process name. Version number in integer. Version name. System support, it's for 64-bit support. Remember, these are common for all processes. Remaining details depend on the process. Like I said before, it will get all possible information. Why we need this? it will be used for app modding and modifying data. And also, if you want to give your scripts to someone, then if the person has a different version, the script might not work as expected. So, we can use this to compare the details. If you buy any paid scripts, observe it. They will definitely use this to compare the scripts, or they will inform you before purchase, like this only works with a particular version or package like that. Now let's see how to get the package. Example. See, we got our process package. Here I am comparing the package. So according to that, the code will execute. If you want to check if a particular package is installed or not, we can use gg.isPackageInstalled function with the package name it's required. See, we got true, meaning that package is installed. Now we know how to check the target process to run our script. But what if our script only runs for a particular version of GameGuardian? If the old version doesn't support some of our functions, because the GameGuardian API will improve by the developers like all games or APKs. So if we use the latest one with the latest functions which are not supported or included in the old version, then those can't access, right? So to check that, we have the gg.require function. Even I don't know my GameGuardian version and build number. But just now, we saw the MT Manager APK's build number version number. Remember, we only need to compare GameGuardian version code and version name only. Just for example, I am taking this. Version means version name and build means version code. Format is important, watch closely. You need a newer version of GameGuardian to run this script. At least version 2.16.1, 240.62696. You have version 101.1, 16142. See, it says our GameGuardian has version 101.1 and the build number is 16142. Now let's see how to format the string. For this, I use a scenario as an example. In pointers, it stores value addresses in decimal numbers. If we convert that number into hex, then we get the address. Then only can we search the address to change the value. For that purpose, we need to use formats. And you already know that nowadays games keep changing their addresses. For that, we use pointers. We have two types of pointers, single-level or multi-level pointers. You already know how to find the pointers, so I am not explaining it again. See, I copied my pointers here. Example. So let's search the address of coins. Let's get the first value. Now let's take its value in a variable and name it something like decimal address. Now let's format this. Before that, let's see our format list. String formats. %d formats a number as a signed integer. %i formats a number as a signed integer, same as %d. %o formats a number as an octal value. %u formats a number as an unsigned integer. %x formats a number as a hexadecimal, lowercase letters. %x, formats a number as a hexadecimal, uppercase letters. %f, formats a number as a floating point. %e, formats a number in scientific notation, lowercase e. %e, formats a number in scientific notation, uppercase e. %g, automatically chooses between %f and %e based on the magnitude of the value. %g, automatically chooses between %f and %e based on the magnitude of the value. %c, formats a number as a character with the corresponding ASCII value. %s, formats a string. %q, formats a string in a way that can be safely read back by Lua, adds escape sequences as needed. %p, formats a pointer, useful for debugging. We need the hex format, so I use %x. And give the value to format. Our value is stored in a decimal address variable, so I gave it. Now we got our hex value. Now clear the previous search results. Now let's do that address search with our hex address. We are using the same format to search, so you can make a function for this. But now I enter the code again to show you better. After finding the value, I am going to edit it. See, our value changed. You can do this with the diamonds also, try it. Code integration. See, I use our code in our main script. And if you observe, I use a normal list edit to coins with freeze attributes. But for diamonds, I use a normal edit. This is the power of coding. Now we have covered the basics to intermediate. In our intermediate to advanced scripting, we are going to cover more interesting hacks. Automate game hacking. Custom user interfaces. Logic and control structures. Integrate with other scripts. Advanced value encryption and decryption. Game logic manipulation. Mainly, the most awaited topic on networking and multiplayer mods, debugging and analysis, and a lot more. Get ready for the main picture.